Today we're going to learn how to add and subtract rational expressions. A rational expression is nothing more than a fraction, so we're really going to add and subtract fractions. Let's go over the rules for adding and subtracting fractions. When you add and subtract fractions, you have to have a common denominator. Once you have a common denominator, you always bring over the denominator and then add or subtract the numerators. Last but not least, then you simplify your answer. So in this case, we will actually factor and cancel if we can. All right, let's take a look at number 1. In number 1, we already have a common denominator, so we're going to bring it over. We're going to combine like terms on the top because it's addition. I have a squaring, so I'm probably going to want to keep it in standard form. So I have x squared minus 4x, and the 5's cancel out because a negative 5 plus a positive 5 cancels out to 0. All right, so there's my answer when I add it. Now I need to see if I can simplify it. So the object of the game will be to factor and cancel. I'm going to GCF out an x and get x minus 4. And on the bottom, I'm going to do prime factorization. And what can I cancel? The only thing I can cancel out is an x for an x. So my final answer will be x minus 4 over 2x. That one was pretty easy. So let's move on to number 2. With number 2, it's nice because I have a common denominator. So I bring over the denominator. Now, looking at the numerator, I'm subtracting, and I'm subtracting more than one thing. So I'm going to have to do that additive inverse thing that we learned how to do in the beginning of the year. All right, so I'm going to bring over the 7y minus 3, and then distribute through the negative 1 and get a minus y minus 15. So, one more step, bring over the denominator, and I'm ready to combine like terms on the top. 7y take away a y is 6y, and negative 3 minus 15 is a negative 18. Okay, there's my answer for subtracting. So now I'm going to see if I can factor and cancel. So on the top I can GCF out of 6 and get y minus 3. On the bottom it's dots, it's y plus 3 and a y minus 3. All right, I can actually cancel out a y minus 3 for y minus 3. So my final answer would be 6 over y plus 3. Not bad. All right, let's move on. Now we're going to add and subtract, but if you notice with number 3, we don't have a common denominator. And in number 3, the denominator looks really similar. They're both subtraction, but they're in opposite order. Now, if you remember, I think last night's video told us that if we have subtraction in opposite order, they reduce to a negative 1. So, if I multiply one of those denominators by a negative 1, it may look like the other. But remember, whatever I do to the bottom, I have to do to the top. So let's try this, since knowing that if they were in the form of one on top of the other, I could reduce it to a negative 1. So I'm going to multiply the second guy by a negative 1. But whatever I do to the bottom, I have to do to the top. So I'm going to rewrite this. I have 2x over x minus 4 plus negative 8 over negative 1 times 4 is a negative 4, and a negative 1 times a negative x, a positive x. So now I have x minus 4. Wow, by doing that, I was able to get a common denominator. So when my denominators are exactly the same in its subtraction in opposite order, all I need to do is multiply one of them by a negative 1, and then I'll have a common denominator. All right, so I'm going to bring over the common denominator, and I'm going to combine like terms on the top, so I have 2x minus 8. I'm ready now to factor and cancel. I'm going to GCF out of 2 and get x minus 4, and I bring over the x minus 4 on the bottom. So right now I'm going to be able to cancel out an x minus 4 for an x minus 4, and I end up with 2 over 1, which is plain old 2. Remember what we said. If you have 1 on the bottom of a fraction, it's not necessary to put. But if there's a 1 in the numerator, you have to put it. All right, let's take a look at number 4. I need a common denominator. Now, they're not in opposite order of subtraction because they don't look the same at all. So I can't use what I did in number 3. I'm going to have to now try to find a common denominator for x minus 3 and x squared minus 9. So the best way to do that when you're talking about binomials or trinomials is to factor the denominators to see what you have. Well, I can't factor x minus 3 anymore, but I do know that x squared minus 9 is dots, so it's x plus 3 and an x minus 3. All right, and looking at that, it looks like they both have an x minus 3 in common. And if I gave the first guy an x plus 3, then they'd have common denominators. So that's what I'm going to do. I'm going to write it as x plus 3 and x minus 3 as my common denominator. Okay, so what did I do to the first fraction so it looks like what I have now? You're correct. I multiplied top and bottom by an x plus 3. So, x plus 3 times x is going to be x squared plus 3x minus, what did I do to the second fraction to make him look like my new denominator? I really did nothing because x squared minus 9 is x plus 3 times x minus 3. So if I didn't change the denominator, I don't change the numerator. All right, I'm subtracting, but I don't have to do the additive inverse property because I'm only subtracting one thing. So I'm going to bring over the denominator of x plus 3 and x minus 3. I'm going to combine like terms on the top, and I have x squared plus 3x minus 18. So there's my subtracting answer. So now I'm ready to see if I can factor and cancel. Okay. I can't factor the denominator because it really truly is already factored for me. But let's take a look at the numerator. Factors of a negative 18, that'll give me a positive 3. Plus 6 and a minus 3. So I can cancel an x minus 3 for an x minus 3. And my final answer will be x plus 6 over x plus 3. Okay, let's move on. If we take a look at number 5, we don't have a common denominator, so we're going to have to find a common denominator. So if I look at it, I can't factor either of them, and they really have nothing in common. So when they have nothing in common, the best thing to do is to use both of them. So I'm going to use x times x plus 1. Okay, so what did I multiply the first denominator by to make it look like the new one? Yes, I multiplied it by an x. So whatever I did at the bottom, I have to do to the top. So 3 times x is 3x. And what did I multiply the second denominator to make it look like a common denominator? You're correct. I multiplied it by x plus 1. So I'm going to multiply the top by x plus 1. And I'll end up with 2x plus 2. I have a common denominator, so I'm going to bring it over. I'm subtracting more than one thing, so I'm going to do the additive inverse property. So I'm going to bring over 3x minus 2x minus 2. Now I'm going to combine like terms. 3x minus 2x is an x minus 2. I can't factor the top. I can't factor the bottom anymore. There's nothing I can cancel, so there's my answer. All right, let's take a look at example number 6. And example number 6 will be our last one for today. Again, I can't add these fractions together or these rational expressions together because I don't have a common denominator. So I need to find one. I really don't know what it's going to be, but I can factor both denominators to see what I have. So this denominator factors to x plus 1 times x plus 2. And this denominator factors to x plus 1 times x minus 1. So they both have an x plus 1 in common. So if I give the left guy an x minus 1 and the right guy an x plus 2, they would have a common denominator. So that's what I'm going to use. I'm going to use x plus 1 times x plus 2 times x minus 1. Okay, so what did I give the original to make him look like the new guy for the first fraction? You're right, I multiplied top and bottom by an x minus 1. So I have to do it to the top and the bottom. And x minus 1 times 1 is x minus 1. So let's take a look at the second fraction. What did I do to the denominator to make him look like my common denominator? You're correct. I multiplied top and bottom by an x plus 2. Or I multiplied, the bottom by an x plus 2. So I have to multiply the top by an x plus 2. And I'll end up with 2x plus 4. Okay, so now I'm ready to combine like terms because it's addition. I'm going to bring over the denominator. And I'm going to combine like terms on the top. X plus 2x gives me 3x. Negative 1 plus 4 gives me a positive 3. All right, I'm ready to see if I can do any factor and canceling. On the top, I can GCF on a 3 and get x plus 1. The bottom is already factored for me. That's nice. Less work for me to do. So now if I look, I can actually cancel out an x plus 1 for an x plus 1. So my final answer will be 3 over x plus 2 times x minus 1. So today we learned how to add and subtract rational expressions with common denominators and with uncommon denominators. I will see you tomorrow in class.